Hi everyone, I have made this little video to help you understand how to do Lab 2. So basically, in Lab 2, I have given you an image that looks somewhat like this. Essentially, what is going on here is that the mainland, right there, is the beach where you would be. That's on land, and it's a 0 feet sea level. Each line has a number, represents a depth. So anywhere along those lines, you have a depth difference. On land, you would draw that, it would show elevation, but we're looking at depth going down, so that the bigger the number, the deeper it gets in the ocean. Now, I want you to notice one thing, that there's some features that make it slightly different in some places, like this, like that. So those are differences in the contour lines representing changes in elevation. But this is how people map, essentially, to show everything, all the changes in depth and elevation in a piece of paper, in a flat surface. But no one goes around plotting each of these points. They estimate how deep it is because they plot a few values, such as you will see in a later question here. They don't go around measuring every single point of the ocean. They just estimate based on the few points that they were able to plot. So let's go back to this. I have to teach you the ocean basin features, which start off with the coastline, where rivers are usually found, at 0 feet of sea level. And then there's a shallow drop-off. We call it continental shelf, which is located on the continental crust. It's just an extension of the coastline, and it's still continental crust, it just happens to be underwater. And then there's a sharp drop, a slope. We call it continental slope. You know, slope means a sharp drop off. Like when you go skiing, you ski on a slope because it's steep. And then it eventually goes to the deep ocean or the flat abyssal plains. Some abyssal plains, like in the Pacific, have volcanoes in them. Some of them are volcanoes that are extinct, and we call these seamounts. So you have all kinds of features here. You have continental shelf dropping off onto the continental slope, and then you have depressions at times, which are considered submarine canyons. They're essentially cracks in the rock. You know, like the Grand Canyon is a crack in the rock in the mountains there. This is a crack in the rock, and it's submarine mountain. Basically, it's a crack in the rock in the ocean. And so you get to the abyssal plains being the flattest regions and volcanoes. Then there's other features, like the oceanic ridge, which is in the middle of the ocean, and that's where two plates are spreading apart from each other or diverging. They're moving away from each other. So when you see it, it looks like two mountain ranges split in the middle, or like a mountain range split in the middle, more like two. A trench is in subduction zones in the Pacific, where you have one plate subducting underneath the other plate as they move towards each other or converge. And this creates a hole, a large depression in the ocean called a trench. Now, when you look at the map, you'll see that here there's the coastline, and it slowly increases in depth. So each line is showing that it goes from 5 to 100 here to 500 feet of depth. So therefore, it took from here to here to get down to 500 feet. So it's a shallow extension of the continent. So you have to think about, what does that mean with the vocabulary terms we just went over? What is this area? It was a shallow extension of the continent. But then you see the lines start getting really close together as it goes from 500 to 1,000 in a shorter time frame, shorter distance, which means that this is a steeper slope or a drop off with a crack in the middle. The closer the lines are together in a map, it shows a drop in depth that's steep. So this area right here is steeper. Now, after it gets to the depth of 2,000 feet, which I didn't draw because I didn't draw all of the lines, we get into the abyssal plains, which are the same depth throughout, so they would have no contour intervals. But notice this abyssal plain has something right there. What does that mean? Well, let's look at this. If this is 2,500 feet right here, this is 2,000, 1,500, 1,000, it means that there's an increase of elevation here, and it goes back into its depth right there. So this should indicate to you that there is a hill there. This is how I would represent it. 2,000 feet, 1,500, 1,000, and then back down. See? 2,000, 1,500, 1,000, and back down. So what kind of feature is this if it's a mountain in the middle of the abyssal plain? So I just want you to think about these features as I'm describing them, and refer to your lecture textbook to help you if you don't remember the definitions. Now let's look at the mainland again. The mainland has something that looks like an outlet, changing the contour lines here. So something's coming from land, affecting the depths here, adding material to it. Then we have islands changing depth, and something else right there. What could that be? It doesn't have an island, but it is something that's affecting the depth because it went from 20 to 10 to 5, going back up and down again. And look at this. This is what I had on the PowerPoint, which is essentially something that is missing here. This doesn't really have a contour interval because all the values are all over the place, so we wrote them down for you. But here, there's a 700 and 800 with 4 lines in the middle, showing that there's a 20-foot difference between each of these increments. So there's a 20-foot contour interval. That means that this is 700, 720, 740, 760, 780, 800. There's 20 feet between each of these lines of elevation change. Now the last part of your lab shows you a bunch of dots and tells you to figure out the elevations of, or the depth, sorry, of 40, 60, 80, and 100 feet. Or meters, I don't remember what unit I use, sorry. Everything should be in meters in science, but that image I had found said feet. Let's say this is meters. So I asked you to get an estimate of where 40 would be. See how I've done it? I started off with a known value of 40. Then I drew it underneath the 41 because it's close to 40, but between 41 and 35 in value. 40 just lies in between those two values. And then I went around here between 35 and 45 because 40 is literally in the middle of these two values. And I go inside because it's smaller than 42 but bigger than 35, back to 40. So it doesn't have to be a line, it could be a circle as you saw there and there. But it should represent all the areas that are the same depth. So I really hope this video helps you to be able to do this lab. If you have any questions, just let me know. I'm here for you guys. Bye.